We are looking at number 3 and 4 from the worksheet packet you provided, 2.1, page 2.1. So we're supposed to determine whether
it is now time to travel.
We're supposed to determine whether or not the sequence is arithmetic. If it is, then find the common difference. So we're only working with arithmetic right now. Arithmetic. So if something is arithmetic, it means we're able to get from one term to the next by adding or subtracting a common value. So if I'm going to set something up that's really easy, if I did like, let's do an even easier one. If I did 4, 7, 10, 13. This is an example right here of it being arithmetic because I could take the second term, 7 subtract 4, 7 subtract 4, and I get a value of 3. Now if I come back here, I should go 4 plus 3, I should get this value, plus 3, and now if I just keep hitting enter, I should get every value in this list, which you can see I would get, right, if I extended this and so on. So let's try up here. Let's take this. We're going to take the second value, which is 5 halves, and we're going to subtract the first value. So I can see here that I believe I'm going down by negative 1.5. So this is my first guess, negative 1.5. So I'm going to come back here, type in 4, and now we're going to subtract 1.5, subtract 1.5, and I need to turn this into a fraction. So let's hit math, fraction, enter, enter. Okay, I got that. Now we're going to subtract 1.5 again. Okay, I've got that one. And now after I do the same thing twice, it memorizes the pattern. I should be able just to hit enter, and we can see we have this number again. So this is an example of arithmetic because I consistently subtracted 1.5. So the common difference was 1.5. This is arithmetic. Let's try the next one. I'm going to take the second term, and I'm going to subtract the first term. And I end up with negative 0.25. Now we can turn that into a fraction by hitting math, fraction, enter, enter. So I believe if this is true, that the common difference would be negative 0.25. So let's try. 1/2 subtract 0.25. Now turn it back into a fraction. It matches up great. Now we're going to subtract 0.25 again, and I better get 1/8 when I turn it back into a fraction. Not only do I not get 1/8, I get 0. That means this is not arithmetic, so I don't have to worry about a common difference. In 2.1, you were only checking to see if it's arithmetic. Okay, so we're going to list these, and we're going to start. I'm going to go back to your packet. Does it tell you to start with n equals 1 or n equals 0, or did he not? He doesn't tell you. Okay, so let's just make a little list here. And this is my input, and this is my output. And I'm going to teach you a really lazy way to do this. And does it tell you how many terms you're supposed to list? 5. Here's 3, 4, and 5. Here's really lazy way. You're going to go into your calculator right now and clear it with me, please. So second plus 712, clear it. Then go to y equals, and you're going to plug this in. Now there's not an n we're going to worry about. We're going to switch n to an x. So 7 plus 5x. Okay, now I want you to hit second table. So it looks like second graph. Let me move this down so you can see. So you're going to hit second table. So here's what it tells me. If I substitute in 0, I get an output of 7. And that makes sense because watch. 5 times 0, my input is 0. 5 times 0 is 0, and 7 plus 0 is 7. If I substitute in 1, I get 12. If I substitute in 2, it is 17, 22, 27, and 32. All of this makes sense. I'm going up consistently by a value of 5. I can see that. You guys are all good with math here. And I'm starting at 7. All of that makes sense. I was able to achieve that by looking at the table. Okay, let's do 7 plus 712. Go up to y equals. And now we're going to go 2 raised to the x subtract 1. 2 raised to the x subtract 1. Then I want you to make your little table, please, like I did before with your a sub n and your n's. So I'm going to do that off to the side. 0, 1, 2, 3, 4, 5. You need to ask, do you want to start at 0 or do you start at 1? That's the one thing you do need to ask him. Okay, and now I'm going to start by doing second graph, which brings me to this table. So if I plug in a 0, I get 0.5 or 1/2. If I plug in a 1, I get 1. 2 is 2. 3 is 4. 4 is 8, and 5 is 16. Okay, let's look now. Let me move this off to the side. Let's look now. And so I'm going to do second plus 7, 1, 2. Let's plug in this next one. So I have 120 subtract 8, and we don't have an n. We're going to have an x. Doing second table, and I'm just putting in these values. So again, when I substitute in 0, my output is 120, 112, 104, 96, 88, and 80. And we could do the same algebraically. Plug in 0, do the math. Plug in 1, do the math. It does not say in the directions whether you need to use algebra or you can use a graphing tool. And lastly, we're going to go second plus 712. We're going to reset it, and I'm plugging out. This is a little different. So we have a fraction. Which number is this, Ruben? This is 8. Okay, so 8, when we have a fraction, we're going to put x in parentheses on top, and parentheses the key here, and x on the bottom. Okay, and here we go. We're going to go second graph. So when I plug in 0, I get 0. Okay, now we do need to know what this goes back to. So I'm going to write it down here, and then we're going to talk about how we can put it in. So this is 0.3 repeating. We'll come back to this. This is 0.5. These are referred to as terminating decimals, so it's just a decimal. We don't have to round it all. When I plug in 4, it's 0.6 repeating. And when I plug in 5, it's 0.7142. We don't want to round unless it tells us we can round. We want an exact answer, maybe written in fraction form. So how can I do that? So I've put these down, and now I'm going to go back and I'm going to figure out how can I write these in a better form. So if I come back here, I'm going to put down 0.333, as many 3's as I can. And most of you will know that 0.3 repeating is the same as 1/3. But then hit math, fraction, enter, enter, and we can see it's going to transfer into 1/3. Same thing. We had 0.66666 repeating. Write it down, turn it into, hit math, fraction, enter, enter. It goes to 2/3. And you're wondering, why did I not do that with 0.5 and 0.6? Because those are exact. Those are terminating decimals. Here we had an ongoing set of decimals. Now, 0.7143. It's even easier just to plug in a 5. So if I substitute in 5, I get 5 on top over 7. So I can write 5 over 7 here. So let's look right now at number 9. Number 9 is not asking us to add up 28 terms. It's saying, what is the 28th term? So like this is term 1, 2, 3, 4. I should know, but by the way, this is term 0, right? This is term 0. So it may be possible they only want us to list these first 5, right? As long as they can see you made a chart here, it should be fine. Okay, so let's come back here and let's just list these down so we can see what we have. So a sub n equals the initial one plus d. Okay, so this is our arithmetic formula. And so the first thing they're telling us is we need to identify the first term. So the first term is 22. I'm going to replace a sub 1 with 22. And now the common difference is, how do I get from one number consistently to the next? This is pretty easy. I can see that I'm just going to add 3 consistently. So positive 3 because it's going up. So this is my formula, but it never asks for a formula. It just simply says, what's the 28th term? And what we do not want to do is go plus 3, okay, that's 34, plus 3, that's 37. That takes way too much time. So to this formula, I'm simply going to find the 28th term by taking my calculator and going 22 plus 3 times, and I'm trying to find the 28th term. 28 subtract 1, and here's my output, 103. And here's the correct way to write it. For this particular function, the 20th term, the output is 103. Look now at number 11. Now what's different about number 11 versus number 9, this was number 9, is here I could just visually see very easily. But if you were not a person that could recognize patterns, if we look back to number 9, you take the second term and subtract the first term. And you go, okay, I think we're going to be adding 3 each time, right? So I come back 22 plus 3, 22 plus 3, okay, yep, that's 25. Plus 3, yep, that's 28. Enter, enter, we can see it works, right? So the same thing down here. Maybe you don't recognize the pattern here. So take the second term and subtract the first term. So I believe we're going up by 0.2, but I want to make sure that's right. So 1.7 plus 0.2, good. Plus 0.2, great. And we can see we're adding 0.2 each time. Now it's a positive. We're adding 0.2. That's my common difference. So I go back to this equation that you do have to have memorized. And my a sub 1 represents the first number in the list. The first number in the list is 1.7. The common difference to get from one number to the next is 0.2. And we're supposed to find the 28th term. So I don't need to do any more work here. I can just grab my calculator and go 1.7 plus 0.2. And we're trying to find the 28th term. 28 minus 1 gives us an answer of 7.1. But how do we correctly write that? The 28th term has an output of 7.1.